Hi, today we're going to talk about a new type of transformation called reflection. I'm sure you know what the word reflection means. You've seen yourself in the mirror before. It's simply a mirror image or a flip of the original figure. Notice when you look at yourself in the mirror, you're still the same size, you're still the same shape, so images of a reflection are still congruent. On the coordinate plane, when we do reflections, they will reflect over a line that we're going to call the line of reflection. We're going to start out with the most simple two type of reflections, both reflecting over the x-axis, the horizontal axis, and then the vertical axis, which is the y-axis. We'll then move on later to other types of reflections. So let's take a look at how to do this. If we're trying to reflect triangle ABC over the x-axis, notice we have our original triangle, ABC. Its ordered pairs are A is 5, 2, B is over 1, up 3, and C is left 1, up 1. And so when we want to reflect this over the x-axis, this triangle is going to be reflected down here into the third and fourth quadrants. Well, that's going to change the vertical shift of the triangle. It's not going to have any horizontal shift left and right, but it is going to have vertical movement. So what we're going to do is to reflect over the x-axis, we're going to go ahead and multiply the y-coordinates by -1. Again, we're doing the y-coordinates because it's a vertical movement that we're wanting to occur. So let's go ahead and look at point A. Point A has the coordinates 5, 2. We want to remember change the y-coordinate because we're trying to make a vertical shift over the x-axis. So our first x-coordinate is going to remain the same. It's going to stay at 5. But our y-coordinate of 2 is going to get multiplied by a -1. So the x-coordinate did not change at all. It's staying at 5. But the y-coordinate is now going to go down 2 instead of up 2. To go ahead and do this for B, again, our x-coordinate is going to remain the same, but we're going to multiply the y-coordinate of 3 by a -1. This will result in the point 1, -3. Notice all we're doing is changing the sign of the y-coordinate, essentially. So for C, again, x is going to remain at a -1, and y is going to get multiplied by a -1, which will result in the point -1, -1. Well, let's go ahead and take a look at what it looks like when we graph this new image. A prime will be located at 5, -2. Label that one A prime. It's a good idea to label your points as you go ahead and draw them, and that way you won't get confused as to what's what. B prime will be located at 1, -3. And C prime will be located at -1, -1. So see, all of our points moved from the first and second quadrant to the third and fourth quadrants. We created that vertical shift by multiplying the the y coordinates by a -1. Let's go ahead and take our ruler and connect it and look at what our new image looks like. Notice we have exactly the same triangle. It's simply flipped over the x-axis. This x-axis is our line of reflection. Now let's go ahead and try to do this with a shift, or a reflection, excuse me, over the y-axis instead. So this time, move down here to this next example, we're going to go ahead and look at our first quadrilateral, which is KLMN. This time I want to reflect this quadrilateral over the y-axis. So instead of it being in quadrants 1 and 4, I want it to end up in quadrants 2 and 3. Notice that's a horizontal movement that I want to happen. I want the horizontal, or the x-coordinates, to be the opposite of what they are. So we're going to go ahead and we're going to multiply the x-coordinates by a -1 this time. It's always the opposite coordinate of the axes that you're trying to reflect over. So when we look at point K, it was 2, 3. So 2, the x-coordinate is going to get multiplied by a -1, which there's a typo here. Let's make this a -2. And then this is our +3. Let me just write this again here. So this is a -2, 3. So for L, we're going to again this time change the x coordinate. Sometimes it's helpful too if you just circle the ones that you want to change, and that way it's easy to remember which ones you're trying to flip. So this would become -5, +1. This one would be -4, -2. And this one will be -1, -1. All I did was flip my x coordinates. Now we can go ahead and label them. K is -2, +3. That one will get labeled K prime. L prime is -5, +1. M prime is -4, -2. And M prime is -1, -1. So this took our shape and it reflected it over the y-axis. Take your ruler, connect your points in exactly the same order that they were connected in the pre-image. And now you have an image that's been reflected over the y-axis. Notice there is my line of reflection. Now something to note about this, if it's a pretty simple reflection that you're doing, is when the shape is over the axes, it's a really simple line to reflect over. Notice that K is 2 units to the right of the axes, so K prime would have to be 2 units to the left. Same thing with N, they're the same distance away. M was here 4 units over, so same line, 4 units over. And L was 5 units over from the y-axis, so it will remain 5 units over. So that's something that's easy to do when you're doing it over the axes. It's slightly more complicated when you're doing it over a specific line. We'll take a look at those examples next. If you haven't already done so, please make sure that you have filled in your notes so far. I will be checking those in class. So everything that we've done here on the video so far should be written down on your sheet of notes. These will get put into your interactive notebook. Okay? If you have any questions before we move on, go ahead and pause the video or rewind it and watch over again. Make sure that you get these two x-axis and y-axis reflections down before you try to move on to the next type. Now I'm going to go ahead and we're going to look at how to reflect over a specific line. Okay, it's important to remember that when you're reflecting over a line, I just want to remind you that we have a vertical line and a horizontal line are probably our other two most common types of line beyond just your axes. So if we have a line that's x equals, for instance in this problem we have x equals 2, that is a vertical line. So whenever it's x equals, that would be a vertical line. This one would cross the x-axis at 2. If it's a y equals type line with just a single number, then that's a horizontal line that would cross the y-axis at that point. Okay, so we want to reflect triangle DEF over the line x equals 2. It's a good idea to go ahead and draw a dashed line at that point so that you can visually see it. I like to do this with another color just because it makes it kind of pop and I don't get it confused with the grid marks or the triangle that I already have. We use a dashed line because it's not a line that's actually part of the actual problem. So this is my reflection line. It's crossing the x-axis at 2, and we know it's a vertical line. Remember, x equals our vertical lines. So what you're going to go ahead and do is you're going to move each ordered pair. Let's make ourselves this note so you can remember it later. You're going to move each ordered pair the same distance on the opposite side of the reflection line. So this is kind of what we looked at doing on the first two examples after we went ahead and looked at multiplying the coordinates. This is probably the easiest way to do your reflections when you're doing it over a line that's not an axis. So notice here, let's look at point D. Point D is 2 units to the right of our reflection line. So point D prime is going to be 2 units to the left. It has to go to the opposite direction, same amount of space. So this is where D prime would be located. E prime is 1 unit to the left of our reflection line. So E is 1 unit to the left. So E prime would be 1 unit to the right. And F is 1 unit to the right, so F prime will be 1 unit to the left. Okay, take your ruler and let's go ahead and connect our points. Okay, so now you can see we still have congruent triangles. They overlap each other because the line of reflection actually went through the original pre-image figure. So when that happens, you can still see though that this is your line of symmetry. And so your two marks will go ahead and overlap each other. Okay, go ahead and pause the video. You might want to try another one of these yourself, or if you haven't already done so, go ahead and make sure that as you watch the video over again, you can go ahead and do this yourself. The last thing we want to try to do is when a reflection's already been done for us, we want to try to describe or write a rule of what's taken place. So let's take a look at the bottom two problems. The first one is pretty simple to see. Okay, when you look at this reflection, again, you can tell that this is the pre-image, and this one is the image because of the prime marks. Okay, so let's take a look at what's happened. Well, you can clearly see that the line of reflection is right here down the middle. All the points are equal distance on opposite sides along the y-axis. Right here is my line of reflection. It's pretty easy to see. So this would be a reflection. It's a reflection over the y-axis. So that's how you would write that rule. It's a reflection over the y-axis. Okay? Now this next one's much more difficult to see. So let's take a look at what we can do to kind of explore what might happen. You'll have some homework problems that are kind of like this one to get you thinking. So let's take a look at this reflection. We can clearly see that it's not over either one of the axes. It's definitely not over a horizontal or a vertical line because it's kind of on a flip here. Kind of see like that. So when this happens, probably the easiest thing to do is to take a look at what the ordered pairs were for the pre-image and what they are for the image, and then look for a pattern. So let's identify our X, Y, and Z ordered pairs. X is left 4 up 1, so it is at a -4, 1. Y is left 3 up 4, so that's a -3, 4. And Z is left 1 up 3, so -1, 3. Now let's look at X prime, Y prime, and Z prime. X prime is right 1 and down 4, so that's going to be at 1, -4. Y prime is at 4, -3. And Z prime is at 3, -1. So go ahead and take a look a second, comparing X with X prime, Y with Y prime, and Z with Z prime, and see if you notice any pattern or relationship. Okay, hopefully you've noticed that X and Y have flipped spots. In this problem, X was -4, and that's now become my Y value, and Y was +1, and now that's become my X value. The same thing has happened to Y and Y prime, and Z prime. So in essence, Y has now become X. So this is a reflection over the line Y equals X. And what this means is that every Y value has now become the X value, or in essence, X equals Y if you wrote it the other way around. Usually you write our lines in Y equals form, but X equals Y would mean the same thing. So they've just basically flipped spots. Well, if Y equals X, that means that they're the same numbers in essence. So let's look what the line Y equals X actually would look like. If Y equals X, then if X is 1, Y is 1. If X is 2, Y is 2. If X is 3, Y is 3, and 4, 4, and 5, 5, and so forth. The same would hold true in the negative. Okay, do you see that this is my reflection line? Y equals X. So we can go ahead and draw a reflection line in there just to make it easier for us to be sure that it is a mirror image being reflected over that line. Okay? And you can see that it clearly is. If you took your piece of paper and folded it over that line, these two triangles would then end up on top of each other. Okay? So when you have a difficult one and you can't see it easily, like over an reflection over an x-axis or a y-axis or an individual just horizontal or vertical line, go ahead and just write down the ordered pairs for each one and then its images afterwards, and look for a pattern, and it should make it easier for you to see. So when you come to class tomorrow, make sure that you have all of these notes for both pages completely filled out. They will be checked for points, and then we'll continue working on these reflections. Thanks for watching.